For any flat shape, we can measure the perimeter, the distance around the shape, and the area, the amount of space inside it. The perimeter of a shape with straight sides can be determined by adding the lengths of the sides, and is expressed in length units like inches, feet, yards, or miles. The perimeter of a circle is called its circumference, and can be calculated by multiplying pi times the length of the circle's diameter. Area is expressed in square units, square feet, square yards, square miles, and so on. For a rectangle, you calculate the area by multiplying the length times the width. Knowing the formulas to find perimeters and areas and how to use them can help you solve problems. Solar energy is used to power homes, cars, and spacecraft. Suppose you need to know the area and perimeter of a solar panel. Knowing the formula for the area of a rectangle can help determine the amount of energy a particular size solar panel can generate. It can be important to know the formula for the area and perimeter of a sail, since each one is tailor-made and has certain specifications. And as long as people have been building structures, they've included geometric shapes like triangles and parallelograms into their designs. Knowing measurements of these designs helps determine the amount of materials needed for construction. Let's look at some examples of solving problems involving area and perimeter. The perimeter of a two-dimensional object is the distance around it. The area of a two-dimensional object is the amount of space inside it. The formula for the area of a rectangle is length times width. Most solar panels are in the shape of rectangles. The energy crisis of the 1970s led to an increase in the price of oil. Since then, solar power has become a popular alternative source for electricity. The sun's energy is used to power all kinds of things, from cars to the Hubble Space Telescope. Solar power is literally out of this world. The amount of energy each panel can provide depends on its area. The amount of material needed to frame the panels would depend on their perimeter. Let's try it. Let's assume that 1 square meter of solar paneling generates 10 watts. That's an area equal to 50 meters times 2 meters. The length of material you'd need around the outside of a frame for that amount of paneling depends on how the panels are arranged. If there are 2 rows of 5 panels, then the perimeter is 2 plus 5 plus 2 plus 5, or 2 times 2 plus 5 equals 14 meters. But if there's 1 long row of panels, the perimeter would be 1 plus 10 plus 1 plus 10, or 2 times 1 plus 10, and that equals 22 meters. The area is the same, but the perimeter changes when the arrangement is different. Architects routinely incorporate triangles into their designs, usually to add strength and rigidity to a structure. The triangles are often combined into rectangles, squares, or other parallelograms as separate design elements. Calculating the area of a shape, like a building's facade, or its perimeter, like around a window, helps solve the problem of how much material is needed for proper construction. A rectangle's area can be calculated by multiplying its length times its width, which can be seen as multiplying the lengths of its base and its height. A non-rectangular parallelogram also has an area of the length of its base times its height. A triangle has an area of half the length of its base times its height. See how a triangle can be made into a parallelogram by adding another triangle of exactly the same size and shape? The triangle has half the area of a parallelogram. That's why the formula is 1/2 the length of the base times the height. Architects aren't the only tradesmen to use area and perimeter. These measurements have been important to sailmakers for centuries. Sailboats use triangular-shaped sails to capture the wind and propel the vessel. Sailmakers can calculate the area and perimeter for each sail using the dimensions of the triangle. Let's say the mast needs a sail that's 20 feet tall. The boom is 15 feet long, and the distance from the top of the mast to the end of the boom is 25 feet. Most sails are reinforced around their edges with various materials. Determining the perimeter of the sail helps you solve the problem of how much will be needed. For the perimeter, we add the measurements of the three sides, 20 feet plus 15 feet plus 25 feet, which equals 60 feet. The perimeter of the sail is 60 feet. But how much material do you need for the actual sail? You need to know the area of the sail for that. So multiply the base times the height, and then multiply that by 1/2. It's the same as half the area of a parallelogram. In this case, a rectangle with the same size height and base. 15 feet times 20 feet is 300 square feet, but that's for a rectangle twice the size of this triangle. Multiply 300 times 1/2 to get the area for the sail, 150 square feet. Can you think of something that has a circular shape? Some swimming pools are circular in design. Calculating the area and circumference can help you solve the problem of how much material you would need to make a cover that would fit over the pool. So let's get started. A pool needs a cover on it to keep out the bugs and leaves and reduce evaporation when it's not being used. Suppose you're responsible for figuring out how much fabric is needed to make the cover. The pool is 20 feet in diameter, so how much fabric is needed? You'll need to determine the area of the pool, and to do that you multiply pi, or about 3.14, by the square of the radius. In this case, the radius is half the diameter, or 10 feet, so the area is about 3.14 times 10 feet times 10 feet, or about 314 square feet. Now you know how much fabric to order, but you'll want to get some extra to be able to make it into a circle.